Welcome to Vegas Programmers. Yes, thank you. You rock. There we go. Okay, that's the energy I like to see. We should have had that same energy at the demo time one. All right, so I'm Joshua Copeland. I am CTO with Remote DevForce. I build software. I have been for over 10 years. This is my grandfather's jacket. It is from Vietnam. So, no, I'm not trying to cosplay up here. But yeah, I kind of am. I haven't been in the military, but he gave me this jacket, and it matches the boots. So yeah, deal with it. So we have an awesome speaker, Andrew Blum. Everybody give a round of applause. He has a talk on data integration, the theory of everything. Mm-hmm. I'm very interested to hear about this because there was a movie called Pi. It was really low budget, but the guy was trying to find the magic number. This number was basically the algorithm for everything, the number of the gods sort of thing, the number of life. So I don't know if maybe you found that number just now. Oh, okay.
You gotta try to hold your head first.
Oh, hey, we have somebody that actually saw the movie. Yeah, I love it. Cool, and second one. And Darren Afkowski, he's a great film director. Anyway. So at the end, we'll have a little bit of open time for questions, as well as setting topics for next month. But I guess as the talk goes, is it okay if people ask questions during it?
Can folks hear me, first of all? Do I have to speak up?
I'll give you this one, too.
All right. Yeah. So I actually prefer to be interrupted, unlike many speakers. So you can ask a question at any time. I might not recognize you if I'm in the middle of a point, but argumentation and saying you're crazy and challenges are awesome. I look forward to them. So feel free to speak up at any time as I present.
Sweet. All right, so just a couple of shout outs. Thank you for Vegas Theater Company for hosting us. Thank you to Corporate Co-working. They're a co-working space here in Las Vegas that sponsors a meetup as well. They give out free day passes for all of you lovely people. So feel free to check out themeetup.com for more information on that. We are looking for a recruiter sponsor as well. There are a couple I'm talking to at the moment, but we want to get an exclusive with a recruiter because we have people looking for work and very talented people at that. I think I see a few of them up there. Yeah, boom, right there. Maybe a little bit, yeah. All right, so let's dive right into it. So again, Andy, and also another thing is at the end, I would like to open up for topics for next month, but Andy does have another talk that will probably get scheduled sometime later this year or something like that. So yeah, let's go ahead and dive right into it.
Hey, thanks. How's everyone doing? Awesome. So this is the first time I'm speaking at a public event in probably like 20 years, but I think I should do fine. So if I don't, and I also do not have a formal presentation, but that's intentional because I like to speak extemporaneously on the subject matter in hand because I'm an expert in it, and these are all ideas that are built up after, out of first principles that I've come up with. And so that's what's going on. We'll switch back and forth between some like stock presentation that I do have, like a page here. We'll dive into code on GitHub. We'll go into a lot of time on the philosophy, and I'll start with the talk, even though I'm talking about what I call data integration, the theory of everything, and you will see the E = formula very soon. That's worthy of the name of theory of everything. But this all comes out of a 30-year career that I've had, and I reached a point, here, let me just, oh, damn. All right, hold on, put this down. So just as like kind of bona fides. I've built up a career from the early 90s. These are all companies that I've done independent consulting for. I've done it at the highest levels, mostly in New York City, mostly as a lead software architect on projects. So I know I've been an engineer my whole life and I'm self-taught. So being self-taught as an engineer sort of gets me to think a little bit out of the box. And I just want to highlight one of those, Johnson & Johnson at first, you can't see the text, but in 1997, they worked on their first data warehouse ever. It came to existence because they tried to negotiate with Walmart and got their lunch handed to them because Walmart knew more about their cost prices and other facts about the things they sold than J&J did. And it was because Walmart was a pioneer in data warehousing. J&J said, we're not going to get like rolled in negotiations next year or next 2 years. We need our own data warehouse. I led the effort to build the first front end. And then you can go forward. I don't know if it's on there or not, but there, yeah, Delaware Investments, fourth one over. Delaware Investments in the 2000s and mid-2000s, right after the financial crisis. I don't know if you remember the time, but companies had to raise money, and they had to raise money quick because big, huge companies were like, the federal government was like, nope, you don't have enough capital reserves. So what happened is that there was a company called Lincoln Financial, still exists, they're a huge conglomerate. They owned a mutual fund and they sold it to an Australian bank called Macquarie. And my software became kind of crucial in allowing that integration work to go through, replacing essentially the mainframe computer that they had, which was a giant ETL machine, and we had 5 months to do it. And the software that essentially is the essence of DITTOE, or what became DITTOE in terms of like a philosophical outlook on how you think about ETL and how you think about data integration, it was done in the mid-2000s on that project. And I guess last going forward, before I left corporate America, you'll see Cognizant on there, the third one over in Anthem. So I never thought I should be public with this, but I think I should be authentic more than anything else. I was a senior manager for Cognizant's big data practice. I brought a design to them that would have resulted in 9 engineers from the client side, our client hiring 9 engineers. There was one big problem that they gave to me, and one huge problem. They said, Andy, my boss said, Andy, we have a problem. And I said, what is it? I kind of knew what it was. And here's the deal. They had already sold a 50-person project. And my design through engineering only called for 9 people. And that's a big problem when your bonus and your Christmas bonus and your career is dependent on selling bodies. And this is like the real life experience that I've had, where I felt my engineering and my architecture design got to the point where it became threatening to others. And that's when it was time for me to go on my own. So in 2020, in the middle of the pandemic, I said, screw this, and I launched my own effort, spent hundreds of thousands of dollars on my own money building the software that I'll demo small pieces of it today. But it's really, I'm not trying to sell this software. What I'm trying to sell to you today is an approach that I call augmented engineering. And augmented engineering is kind of like the dark art secrets that you're not taught in school, and thought leaders won't teach you, because at the end of the day, it means a lot less bodies that they sell. And there's 3 million employees who are IT consultants for large consulting firms. It's a major, major business model. And everybody kind of has to toe the line, and then everybody gets paid and everybody's happy. And the senior manager who works for the company says, well, I'm not going to be fired because I brought in Cognizant or Accenture or Deloitte or pick one. Doesn't really matter. It's all the same. They're providing bodies. And the engineers are like, hey, I'm getting to work on new technologies. I'm working with these thought leaders. And marketers come up with new names for the same things. And over a 10 or 20 or 30-year career, you see that. And the world rolls forward. And everybody who's been doing this for a while knows it's the truth. So I'm trying here to break that veil. I'd like to be giving this speech on LinkedIn for thousands or hundreds of thousands of people in the industry, and this is the first time I'm shopping it out. So thank you for the opportunity. I really appreciate it. I moved to Vegas a year and a half ago, and this community has been really helpful to me to kind of think that I can take it to the next level. So appreciate that. So with that, I'm going to get right into to data integration, the theory of everything. And this is a 40-page white paper, which I'm not going to go over, and it's unpublished. But I'm going to get just straight to the logic of my thoughts here, and then show you the implication of how we built software around that logic and what it looks like. So I don't know, can everybody see the S arrow T on top? Anyone in the ETL field at all? Do data integration work? Okay, so S arrow T, kind of everybody in the field knows, and it's just an abstract symbolism for source to target, where the arrow represents whatever the abstract behaviors are. And I'm not inventing this. If you're in the field, you've seen S arrow T explained by vendors, and it's kind of like the only abstract symbolism, and then life stops in the abstraction, in the symbolism, and no one's ever added to it that I've seen over the last 20 years. So I went through in explaining what I was doing, I went through and started adding to it, and out of it popped a formula that I call data integration, the theory of everything. And I'd like to take you through the logic step by step. So first, source to target. It's kind of obvious. Anything we do in data integration is moving data from a source to a target. And then a little sophistry down below. So that means every data integration routine that's ever existed move data from a source to a target. It's quite obvious. You take the next logical leap. A single data integration routine by definition moves data from a source to a target. So every data integration routine that's ever existed moves data from a source to a target, right? And that's not saying anything profound yet. Now, some of this is meant to be kind of an inside joke, and it's highlighted there. If you see up here, what I have is FADS under both the source and the target. So that stands for files, APIs, databases, and streams. Now, I labeled them as fads because it's a joke. They're the least fadful thing in the history of computing. Files have been with us since 1970. Databases have been with us since the early 80s, late 70s. Streams have been available to us since Unix, since sockets have been available, right? So, and APIs, I guess somewhere in the early 90s, we started programming against APIs that were, or mid-90s, that were web-based. So again, I think this is a unique thought because most managers or even practitioners say, oh my God, I have to move something and we have it locally on SQL Server and I gotta go to Google Cloud. And they're so focused on the individual source and the individual target that they actually very much miss the forest for the trees or whatever analogy you want to use, because it doesn't matter the source or target. By definition, the arrow is all the same. You're running a series of behaviors in the middle. And it's those behaviors and how that you run them are important, not the specific source or specific target. And I'm sure you've all been, if you work in IT, if you're a programmer, you've been around some type of conversion where a company was saying, I'm switching databases or I'm going to a new cloud provider. And careers are made out of these projects. These are projects that come up infrequently, once every 5 or 10 years. But it seems like cloud is all the new thing, for example. But before that, companies were moving from local RDMSs to Teradata. Before that, they were moving from the mainframe to local RDMSs. So throughout the history of my career, this has always happened in one form or another, and I wanted to be able to tie all this work together. So now, if you go further, and this is the end of the formula here. Let me get rid of this menu and make this a little bigger for you guys. I added another thing called BAPD. And so what does BAPD stand for? It stands for begin, acquire, process, package, transmit, and end. And I make a controversial statement. I'm saying any data integration routine that's ever existed in the history of data integration routines, that ever will exist in the history of data integration routines, can be thought of with each of those behavioral abstract concepts: begin, acquire, process, package, transmit, and end. They can be thought of as swim lanes in any type of data analyst spreadsheet. So if you're struggling how to explain your data, what an engineer is supposed to do, you can start with those swim lanes. Yet, I've never seen it before. I've never seen anyone start with those swim lanes. And we'll talk about that a little bit further. So before I go on, like, this is literally the formula, and I can spend the next 6 days talking about the implications of this formula, but how much time do I have left? I'm not tracking, I'm bad at it. What?
35 days.
35 minutes?
Yeah, you're good.
Cool. So does anyone have any questions on this conceptually? I'm going to stop now and open this up for conversation before I go into a demo and we can have more talk. Please.
Is this formula referring to the persistent data or transient?
I'm sorry.
Are you referring with this formula to persistent data or transient?
Well, it's transient data that becomes persistent, right? So it is persistent data on the source and it's persistent data on the target, right? Like, for example, you're moving something from a persistent file that happens to be up on SFTP, or you're moving something from an AWS S3 bucket. That's persistent data. But in the pipeline, it becomes transient, and then it has to finally rest and be persistent again at the target. So it really speaks to processing both sides of that equation.
But not every piece of transient data will become persistent.
I'm sorry?
Not every piece of transient data will actually become persistent.
Sure. I mean, I agree. Sometimes transient data is used in memory and thrown away. Like, it feeds its purpose. But everything that is considered extraction, transformation, or loading, or data integration does start out as persistent data, does go through a transient channel, and then becomes persistent data again by definition of the kind of data integration ETL concept. So I'm only speaking of its use in that,
Yeah, in the linear program.
in that concept. Okay, anyone have any other questions before I go on? Okay, so now let's go down and be like, all right, what's happening? So I'm here to also teach about data integration. So what's happening in the arrow? What can you organize within this BAPD concept? What does data integration mean? What do we really do? So these are 20 different behaviors. I think it captures about 95% of the things I've ever seen in a long career doing data integration. And these behaviors can be plugged in. Again, we're speaking abstract now. We'll get to specifics in a bit. And so just to kind of go over what data integration does, you may need to format the data. Like, you may have data that's sitting in CSVs and you're doing some wacky big data stuff and you want a columnar data store and you have to move it to an Avro format. Or you have something in CSVs and you're like, hey man, like, my engineers need JSON, so I got to move the CSV to JSON. But all those are basically formatting style behavior. You have source retrieval. I don't need to go into that, but obviously you need a mechanism to retrieve data from the source. And one of the things as a Java engineer that I've been very wary about watching this ecosystem grow of big data tools is you'll see in a lot of cases the first implementation of the tools like Spark, which some of you may have heard of Spark. Before 1.5, it used total Java memory to manage its pipelines. Well, Java memory goes on the heap, and then there's garbage collection that goes on top of that to collect it. And when they figured out why the hell they couldn't process big data, even though they were a big data tool, they came to the conclusion that managing things off heap was really important. So source retrieval is like retrieval into what? It's retrieval into an engine that operates on that data running an arbitrary series of behaviors. And these are type of things that if you opened up an ETL tool, you can probably drag one of these components and drop it on a canvas if any of you are familiar with AWS Glue. And I want you to think about this. So if you go and you learn how to write AWS Glue, which I won't call it code, but it can be, right now, they'll give you an example and they'll say, oh, here's an example from taking some data from a local file up to Postgres on the cloud or Aurora or wherever, or Redshift or wherever it's winding up. But the point is they're giving you a single drag and drop screen to represent that single routine, which makes a lot of sense because how else would you do it, right? But then if you work for a big company and you have thousands of data integration feeds, right? So now you have thousands of these screens that each represent your flow, and some regulation changes. Something happens underneath into the business where all of a sudden what was PII, personal information, expanded, let's say. And now you have to go through all your data integration routines to handle the fact that the PII, well, what does that mean? It means if you're a big company, you're hiring Deloitte or Accenture, and you're bringing in their consultants because you don't have the bandwidth to change thousands of routines, and some VP of data management is going to make their bones on this project. And they're going to get great bonuses because they were able to comply in time with the regulatory requirements when it's a Herculean task to change thousands of things to comply, but it doesn't have to be that way. All these hero quests that we face within corporate America, a lot of times if you had a different architecture, all that work would never need to exist in the first place. And that's what I think I'm suggesting and I'm putting forward here, but we'll go on. So we have target, insert, and update. It's obvious. You have transformation in the middle, right? Like you may do more than formatting. You may apply some functions to the data or something to transform a string into a date or vice versa. You have encryption. You want, and this is a behavior that has to be expressed. We won't go into detail. Everybody I think knows what encryption is, but you want your data to be safe, not just in transit, but also at rest. You got a log, you got an instrument. What's instrument look like? Well, what are the start times, stop times, and errors for every data integration routine that your team runs for the last year? Can you break that up? Is someone's operation sophisticated enough where you can have that information and tell that to me? Can you break it up by zone? So you're not, what is zone? By development environment. So you can see that data across dev, QA, stage, and prod, because it's not just operational. That data can tell a senior manager that the status reports they're getting are full of it, because it's real physical data about how many times a QA team ran and did their job running specific data pipelines. So now you're getting information that's just different than the traditional status report, bubble up the chain. You got new metrics. You got things like deduplicating, being able to have your schemas evolve. It's not that simple because maybe your data provider changed a field on the fly and maybe your routine blows up, but there's sophistication available so your routine may not blow up. And that's called schema evolution. Your pipelines inevitably are going to fail, but how robust are they? They're running at night. Most companies I know have some type of lights out team in India. These are giant companies, and basically with those lights out teams, they're kind of the computer operators of old on the mainframe, and they're watching these routines overnight. Why are they needed? What if the pipeline could rerun on its own and had retry capability? Why aren't we building robustness into the things we do? If AI is going to succeed, data needs to be like a utility. We've heard that the cloud's like a utility, cool, but the data that's coming off the cloud is very much not like a utility. You have teams and operations that have to be there to support it. And it's frankly not necessary in many capacities, or a lot of that labor can go away with smart software ideas. You have micro batching, right? JDBC, I believe, has a limitation of 1 gigabyte per connection. So if I'm moving an historical, which I'm doing now for a client with our engine, if I'm moving 75 gig historical data source, I got to batch it up. I can't take 75 gigs in one shot, right? And you obviously, I support a lot of AI teams. I'm kind of like, my pitch to AI teams is, hey, you don't want to be doing the mongering and the pain in the ass stuff, and I'm like the best sewer guy on the planet. I will bring you this data. It's not sexy to reformat it and do these things. Like, data engineering inherently is not sexy outside of AI context, but it's absolutely necessary so they can focus on the data science things that are helpful to them. And very, very important, custom code. You can't think of everything. I can abstract till I'm blue in the face, but there's going to be in a scenario where someone wants to run something that I never thought of, or an engineer, so you need to be able to run custom code in the middle of a pipeline, and that custom code needs to be able to go into your data structures, retrieve, manipulate data, put it back in before it heads to the target. So when we look at this and we look back at the formula here that we started with, right? This now, what I'm saying and what DITTOE is, data integration, the theory of everything. DITTOE, get it? It's the second joke concept. DITTOE used to be like a memo and a copy, and I made that match. But anyway, the E is everything. The sum is a collation of these routines. Every data integration routine that's ever existed in the history of the planet moves data from a source to a target. There's always a series, or usually I'd say a series of behaviors in the middle. Otherwise, it's called a copy command. Because the simplest data engineering routine is it's called copy, and we all know how to do it. It ain't that fancy, right? So you're usually expressing some arbitrary behaviors in the middle that a copy command can't handle. You move to a target, and you're always moving to another file, API, database, or stream. And along these swim lanes that I call BAPD are 20 or so behaviors that every data pipeline at least expresses some of those behaviors. And that is a new way, I believe, of looking at to data integration that no one's ever pieced together kind of in this approach, in this way. And it's had profound implications for the software that I've built. And I'd like, before we go on, I want to ask if there's any questions or thoughts. And anybody? Yeah?
So when you're tackling like a new project,
Mm-hmm.
you kind of go through, is there a checklist that you kind of go through this formula?
Yes, but it's not much different than any checklist that people would go through. You got to know all your individual sources and where they lie. It's very common now that some data is going to come from SFTP, some data is going to come from a relational database, some data is going to come from the cloud, some data you're going to do API lookups into, like, you know, I guess we did a Salesforce API lookups for some of our data and went from Salesforce to someone's data warehouse with this concept. So those steps are really the same. You have to iterate your sources and your targets very carefully.
Good question. The integration means that you put something into it, or you integrate with something.
Yeah.
What happens is, let's say, for example, I work with a company that just sells data.
Yeah.
If it's not integrated, the client comes in and says, I want this data processed this way.
Yeah.
The client says, I want to process different. Same data, the client is sending.
Yep.
So data is not integrated. They're selling data.
There's a lot of data providers I work, just so I can speak to that specifically. So I work, my first client is a company that's using this software is a company called Votivate. And Votivate has a few terabytes of election data.
That's exactly what I was
Okay, so, and And so in election data, like one of the providers, not all, most of them provide the same info because there's only one voter in a district, but there's a bunch of different providers that people trust in the industry. And I have access right now to 10 billion attributes. And what I mean by that is specifically name value pairs associated with all voters in the United States, of which there's approximately 200 million of them. So but there's 10 billion, so you can do the math of 10 billion divided by 200 million to see how many attributes per voter. But there are hundreds of potential attributes, even thousands of potential attributes, if then you start mixing it with consumer files and different consumer information. And yes, someone is purchasing that data. Well, in this case, it's Votivate, but they have to integrate it, right? And up to this point, it's taken them, and this sounds crazy, but it's taken them, the way they organize their routines, it took them 1 to 3 days per state to load, California being 20% of the country, so it takes a little bit more time. So they were always behind on their data, and we believe we're going to be able to take a real life load that works in a real life production situation and make it 50 times faster with our techniques. We think we're going to get this down to 8 or 12 hours, but we're for the whole nation, but we're not really sure yet, so I don't want to make any promises because it's like this weekend we're going to finally like hit dev with everything into their dev database, so we still don't know how long it takes, but that's our guesstimate that we're going to be improving things by a factor of 50x. Anybody have any? Yep.
What are your biggest bottlenecks that you're running into?
Memory. So I have very much an edge node strategy versus a Spark distributed strategy. So where I'm running things, I have a box with like 192 gigabytes of RAM on that box. So even what happens is like a lot of times routines have to be built in SQL heretofore because you need the cache references and the lookups, right? And like, sure, there's tools like Memcache, but usually the pattern is people take data, they bring it down to disk from some source, they bring it down to disk, and then they move it to some, what they call landing zone, that's the disk, and then they move it from that landing zone into an ingestion zone in a data warehouse, and then maybe there's a confirmation zone, there's other zones before it finally hits what you would consider a production or a publish zone. And that's the state of the art of the technique in data warehousing. And each step of those transformations are very much SQL along the way. And my theory of the case, which is still a hypothesis, and I have one more feature to build out in my system before it can not be a hypothesis, is actually relying on SQL to do string manipulation is like really dumb. Just at the end of the day, like in abstract, SQL is not the best metaphor for trimming. I used to run stuff on Oracle, like I'd see routines like, oh, just make sure your spaces are trimmed from your field, and it would take, over huge data, it would take hours and hours for that one little step to run because SQL is just really inefficient. Now, I'm sure it's faster now. I'm going back a decade or more from when I observed this, but it's very much influenced me that SQL is just not the right language to do string manipulation in.
In the SQL, the index is still down kernel.
Yeah.
And versus some other non-SQL databases, for example, it's 100% where you can actually do indexing customers.
Yep. And when you, and it gets worse if you have clustered indexes, but sometimes you have to have clustered indexes because you need it sorted in the same way. And then it's like, oh, well, you can do partitioning, and partitioning is great to a point until you're partitioning every congressional district in the country as your partition of voters. And you're like, well, why are you doing that? But then that makes sense in a way too, because you can't update all the voters at once in a transaction or you'll lock your production system. So if you do it by congressional district, all right, like worst case to the worst, 400,000 voters are locked for that period of time, not the whole nation. So, these little architectural choices that people make have significant downside effects that no one realizes until they experience the downside effects. And that's the type of stuff that I want to lecture to you guys over time, like from my 30-year career, from the war stories that I've had building stuff and the successes. So any other questions?
If we have other questions, just reiterate them so the YouTube viewers can get more.
Oh, I'm sorry. I didn't know. Hi, YouTube viewers. Yeah, does anyone have any other questions? And I will repeat them.
We got like 25 more minutes.
Okay, well, I'm going to switch over to a demo, and I will not try to I will not try to expand on anything. I just want to make sure I cover my topic completely and thoroughly and in a compact way that's beneficial to an audience like this. And if I'm early, so I'm early. So let's go into a demo and see what this actually looks like in real practice. So this is... I started, let me back up before I show this demo here for a second. So what you're looking at is a UI console. You'll see on the left that there are 4 little application icons, tap, perch, EQB, and data brief. They literally are separate applications. They don't, data brief especially does not belong here. But the point is that this technique that I use and you'll see it very soon when I show you the JSON of a low-code document that essentially is passed to an engine to interpret. So when you're writing a new instance, you're not writing new code. You're essentially specifying a low-code specification for what should happen to the data, and that's what this form's about. That is part of a class of programming activities, just what I said in the beginning, which I call augmented engineering. And augmented engineering has, in my mind, 3 pillars to it. One pillar is low code passed to an engine. You're augmenting the engineering that you're doing with a low-code schema so you don't have to write specific programmatic instructions every time. The second pillar is what I would call code generation. Right, you can, I don't know, like you can think about any build engine and archetypes where they successfully generate the beginning of code. You can think about other systems that generate code behind the scenes where you're taking less effort. And then the third pillar now is AI and LLMs. So that triangle, if you will, which I wish I had a slide for, but I don't, for that triangle. But that triangle of code generation and low-code document interpretation with AI at the top, it really is that way. Everybody's trying to, I agree so much with what the last speaker said, which is like AI is really, when it comes to engineering, shouldn't be the base. And although this is not part of my talk, I have some time to kill, so I'll explain my point of view here. You wind up, AI is by nature, LLMs by nature is stochastic. So what does that mean? Well, that means if you go ask ChatGPT or any other LLM the same question, you may get slightly different response. Why? Well, the way LLMs work is they don't pick the best next word. They pick one of 5 of the next best words. And that's a random, stochastic, a random process baked into the LLM. What's the implications for what I'm saying? Let's pretend you're like every app that's ever existed and you need to maintain users. And then you need to associate those users with groups or roles. And you need to associate features with roles in your application. Every application that I've seen has that kind of premise built into it. It doesn't matter who the vendor is, it's ubiquitous across the industry. Why would you want some random stochastic process to write something so fundamental to your security? Yet, it's a perfect type of thing that could be automated because everybody does it. So we've taken the philosophy that we build that by hand. Those things that are hand that should be expert crafted, we build by hand, and then we can use AI on the top as sprinkling to add things in, and that's still in our lab right now. So this is not built as an AI demo, and you won't see our AI features, but maybe you will over the coming year as we build them out. Anybody have a question on that? Yeah.
Referencing vector databases and embeddeds.
I can't hear. Can you say it louder so I can?
Yeah. Were you
Well, I mean, vector databases and embeddings are certainly part of an LLM architecture, right? So, and the vector databases are, like based on word-to-vec routines that are taking all the words and turning them into linear algebra data sets, right? That's my understanding of it. I'm not a machine learning expert, but I feed a lot of experts' data. So I have that perspective on it. Do you want to expand?
Well, the embedding models can be fine-tuned depending on, like you're saying, with the data, it has to have a strong database. If it's fine-tuned correctly, you can use something like a feature extractor.
Sure.
If it's trained correctly, and it can do those types of jobs.
Yeah, but I would make the argument, like the last speaker did, but I can rely on my own on this argument, is like you probably have somewhere to the order of, I don't know, like if I'm looking at architecting a big project, I probably have somewhere in the order of hundreds of thousands of a decision tree that could go in with hundreds of thousands of nodes. As me as an architect, how is this system going to design, right? And so I, at least for right now, can't speak to the future because I've been surprised, but at least for now, and my supposition is you will always, it's basically an AI working with a human being who has subject matter expertise, because ultimately the problem is, how do you break down human communication into the smallest possible pieces that then fit together in some algorithmic like way that we call a system? And I've seen no evidence yet with the chain of thought or chain of reasoning or RAG that we're there yet. We may get there, but we're not there yet. Like I don't see the LLM that can replace me, but maybe that'll happen in the future, and I'm open to it. But what I think more is about 70, and this is bad speaking to programmers, but probably 70% of the engineers won't be necessary in the future doing the work that they're doing now, because you're going to take the cream of the crop of the top 30% and you're going to augment them with an LLM and AI, and they're going to do the work of 200, they're going to do double the work. So I see it as an incredible productivity tool, but if you blindly listen to an LLM, at least now, and I've used the best I can, I've used StarCoder and I've used ChatGPT in the coding section. 4 out of 5 times I can take things, paste, and it compiles, but 1 out of 5 times I'm like, kind of what the hell are you thinking, ChatGPT? This is code that would be produced by a rookie. Isn't it true that this is going to run slower than this approach? So you still kind of need, at least now, that expert to oversee, because 1 in 5 cases is really significant if you're suboptimal.
Yeah, they still have to be product.
So you're saying, like, when you use an AI model and you put in something, I mean, you're going to get a different answer back every single time, most likely.
Sure.
And then the other thing, too, is who checks the AI, right?
And I think that's the role of a senior software engineer. I mean, I don't think AI is going to replace a lot of engineers, but I think at the end of the day, it's going to be humans and AI working together. I don't think we're ever just going to be totally out of the equation. I could be wrong, but that's one of my bets, or else I wouldn't have done what I've done. And the other hypothesis that I have is that, again, like I said, that SQL as a way of moving data is great often, but it sucks sometimes, especially with string manipulation, just like Python is really slow with string manipulations compared to C. SQL manipulation is equally or even more slow than Python. And so if you do things on the edge node before it gets to the database in a non-SQL capacity, there's a lot of sense-making apparatus in there of manipulating data on the edge before it gets to the database. Okay, so let me just show you this so you guys can see what I'm talking about. This is our staging server right now. We have more advanced stuff in development.
Can you hit Control Plus on this a couple of times just to zoom in a little bit?
I can go like that. Okay, can you guys see this?
Yeah.
Okay. So anyway, all this is saying is like these list here each represent a separate low-code routine. So I'm just going to open one of them up. And when it was created, when it was last updated, blah, 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 blah. If I look at CSV to Avro here, which is but it could be any of the routines, and you look at this, and I'm coming over here, and you can view the JSON. This is actually the JSON representation that I said is a low-code representation of this routine. If I go back to the edit field here, and I go to behaviors, I want to pull you into there, you will see my BAPD, right? I said begin, acquire, process, transmit, end over there, and then you will see individual behaviors. So my concept here is with this software is that right now, if you want a large swath of data from a corporate data warehouse, what you're going to do is you're going to call up the data warehousing team. There's no way to really describe it properly, so you're just going to fill one of those generic service desk requests that are very generic where you're describing it. The data warehouse team is going to meet with you, call back. You're going to have chargebacks, the whole corporate shebang of how you cost things internally, and I don't think any of it's necessary. The only metaphors that we have right now are actually you drag and drop, and ETL developers can create a simplified routine. But in this concept, if you see right here, we not only have the BAPD, like schema validation, formatting, compression in the process, you can turn it on or off. And then there's different properties. If you go further, we're moving data from a source to a target, so you can actually, you don't have to do this stuff through a UI. This is a UI presentation, but you can easily write code to look at the source and target metadata. And the final piece of the puzzle, which I cannot demo yet, but it's the next feature I'm building, is an expression language that I call DEAL, Data Expression Analyst Language, because I just like to name things cutely, like Ditto and TAP, the abstract pipe, UDM, the universal data mover. I like the acronyms. So the thing with DEAL is, it's very a Vegas name too. The thing is with DEAL is like, you want, when you're moving things, in order to prevent a developer from having to come up with SQL expressions, you need some type of single line Excel-like functionality that can replace the SQL. So when you want to do that left trim, or you want to find some data and have to do a mid and a position, or you want to have some type of case statement. And the final piece is where I'm saying is, hey, when that DEAL language is being built this year, and that embedded in here, you'll actually, instead of going, when you look at the source to target mapping, when that's built out, you'll actually see here, transformation name, transformation expression, and it's blank because we don't have it built yet. But that's meant so an analyst can just specify the transformation, where anybody can use Excel. You know, on some way where they can cobble together two functions in Excel, same type of concept here. And so now within this app, this is the app in our staging and our dev environment. If I showed you that, which maybe I'll bring it in next week, next month, or whenever I come back for a demo, but you would actually see I can turn this into builder mode. And by builder mode is within the app. I know this sounds crazy, but I can add icons and apps within this app in builder mode. And then what happens is, because this relates to the augmented engineering, what happens is users are able to select a template, like I want a typical CRUD template, right? And so everybody supports create, read, update, delete. That's like manifest baseline for any type of enterprise application, right? And so that metaphor, what happens when they go through our templating system, we then go ahead and take that template, generate the React code to support that template through a Java middleware layer, and then have that code be stuck into GitHub on behalf of that analyst or developer. And my vision is, just like a lot of the data warehousing staff is unnecessary, A lot of programmers are unnecessary, but the ones that are necessary are really damn necessary, and they can't use bubble IO. They need source code, and they have to respect common practices. So everything I'm trying to do is steeped within the common practices of engineering, of going from dev to QA, to staging, to prod. Those things will never change, no matter, because that's like stuff that we've built up in 30 years of me doing this work, and it's turned a hodgepodge into a craft. And anybody who thinks they're going to come in and just automate all that away, I don't believe that's the case. You'll always need those type of software engineering things and processes. I think I'm done unless there's any other questions, and entertain them.
And we've got 5 minutes for questions.
So how is this different from, let's say, commercially available product, say, Oracle's Control M?
Okay, well, Control M is very different, because Control M would be a tool that would allow you to instrument and run ETL jobs and small components, right? Like, it's one type of workflow engine that's possible, but this would be something that could be called from Control M. So our jars, our Java jars, can easily be scheduled and called from Control M. But what I find is that batch concept is getting a little outdated, or very outdated, even though most companies run at a specific time. We're going to run this job, and I like to architect things by signal rather than that's other than time. Like, this file arrived at a certain place, but things like it. But Control M has its file watchers, and you can do that stuff. And yep.
So I have 2 questions about what you're building here, and then a third that's not necessarily related to this. But so the first question is, do you have a way to version control what is being built here?
Yeah. So we have that JSON that I showed you. We call it the pipeline metadata document, PMD for short. And so we can version that behind the scenes. I don't believe we're overriding. I believe we're always inserting new rows, but even if we're not, that can easily be done.
Always roll back or something like that.
We don't have those capabilities built into the UI now. And understand my business model, this will turn into product, but I'm not right now, and I haven't gotten into like kind of how I started all this, and I don't have time to get into it, but I backed off $1 million in funding last year. And I backed off of that as an entrepreneur because I was really fearful I was never going to pay myself back on the money that I spent without making my investors wealthy. And that's just the way life works in venture land. So what I decided is I was going to bootstrap, and how I was going to bootstrap was to build a company, and that company's named AndyBlum.io. And we focus on 3 things. We accelerate development speed, reduce risk, and we build great software. And that's my focus in life, and I don't really plan on selling this technology. I mean, like, I plan on spending the next 25 years working on it. This is one piece of the whole system that I kind of consider my career opus, and what I've learned in 30 years expressed that I could not get expressed through employers and traditional relationships. So I really, really, really appreciate all you guys coming out and listening to this. It means a lot that I can kind of share my own truth and my own authenticity. It's been 4 years of effort getting to this point, from the time I decided to walk away from corporate America to this point, standing here and acquiring my first clients. It has been an easy journey, and I thank you.
That you were going to do, I want to get you a spot for demo time, but was this the actual?
Well, this was part of the demo. Obviously, you can go way more.
Is this going to be a SaaS one day then? Or?
Yeah, so when we productize, and it's a strategic decision to productize, but my goal is to embed forms like that in ServiceNow all over the country for help desks. Oh, sorry. And also to essentially allow people in the first cut to take their proprietary cloud data, but I don't mean just AWS and Google, but cloud's done the same, like marketplace data, like QuickBooks, for example, or other marketplace data like ServiceNow or whatever it is, and take that data and be able to move it anywhere. And we have to bridge firewalls to be able to do that, and I can talk to you another time on how we're going to do that, but we're aware that you can't just connect from the cloud into a corporate environment and say, move to my production data warehouse. Life doesn't work that way.
I've recently gotten introduced to corporate America with one of my contracts, and boy, the service first tickets and all that. You have to jump through so much red tape to get anything done. It's a little, it's like your hands are tied, you know what I mean?
Well, it's I've worked that way my whole, I grew up in New York, and most of my clients in the beginning of my career were in New York, so I kind of got to see that firsthand. Was very fortunate.
So while we still have you, because we do have a couple more minutes.
Sure.
I wanted to ask you, because obviously you have a ton of experience.
Yeah.
And one of my favorite things I love to hear is war stories. You mentioned it once. And I have some hilarious ones myself, but I'll save those for another meetup. I would love to hear, because obviously, you've been through a lot of different contracts, a lot of different jobs and things like that. I'm curious, if you can think of one off the top of your head that you swooped in and saved the day or whatever, but some context into what the issue was. Or
yeah, I'll go more. I alluded to it a little bit earlier in the speech, but we're now going back to 2009, and there's a lot I can discuss on this, but I'll start at 2009. I can go back further, but I worked for an Australian bank called Macquarie, kind of like the Goldman Sachs of Australia. They're a big, very, very well-known, very wealthy institution. When our economy was crumbling in the financial crisis and companies had to raise money, like I said, they acquired a mutual fund from a large insurance company. Now, what the war story part of it is when I got there, they're like, well, we have this mainframe, Andy, and this is all in an Australian accent that I can't do, but we have this mainframe, Andy, that's run for us, run for Delaware Investments by Lincoln Financial, the parent, that we absolutely cannot take with us. If I take this mainframe into our bank, I will be fired. And the second part of this was, hey, we only have 5 months left. Or we face $250,000 a week fine, and because we will have not met the contractual agreements of the merger, we face $250,000 a week fine, and if we get fined too much, I will be fired. So what are you going to do? So they had already hired out of retirement the mainframe programmer who wrote all the COBOL, and he said, we have the subject matter expert on site. You need to go interview him and figure out how you're going to throw this stuff away. And so here's the war story. The hero and then the goat, because it's both sides of it. So the hero was, I said, okay, I looked into it. We have 5.5 months at this point. I looked into it 2 weeks. I interviewed the mainframe developer, and I said, here's my thoughts. You have 1,200 routines that run this bank. About 900 of them copy files from the mainframe from one place to another. It's not that big deal. They're just basically copying to different network devices. Not that hard to orchestrate. But you got about 300 routines that actually manipulate significant amount of data in those routines. And you have 2 ways of going. Okay, Andy, you're the architect. We've paid you money. What are my 2 ways? The way I recommend to you is you bring in a Deloitte or an Accenture or a Cognizant. They're going to say at 1,200 routines, no problem. We'll bring in 40 or 50 developers. We have the scale. No one else has the scale. These 40 or 50 developers will work on 20 or 30 routines, and in 3 months it'll all be done. It'll really take them 6 or 8, but that's how the game's played, and you'll get your stuff done. Unacceptable. like, again, I'll be fired if I have that much expense. And I was like, okay, there's a second idea. And it's basically this concept that I've demoed for you. It's the concept of building an engine that can interpret low-code documents. And now you only have a few engineers working on the engine, maybe 5 or something, a small manageable team. And you got a bunch of analysts creating the low-code documents, right? And if you do this, it's going to work. And they're like, well, we have no choice because every other path leads to me being fired. So we got it done. They didn't face any fines. That's the hero side. Here's the goat side. When we were done, and I really built a system that I thought was some of the best work I had done in my whole career up to that point, they're like, we're throwing away this system. We're bringing in Informatica, and that's going to be our tool. And I was like, heartbroken, kind of like this thing worked, and I poured my heart and
Was this before the deadline?
no, this is right after the deadline. After we were successful, they were like, now, but it made sense to me. Like, why would they want to bring some custom tool or custom software in to manage their day-to-day? They needed something custom for the exceptional, but the fact that that was pulled away, I couldn't emotionally understand 20 years ago why, like, my best piece of software that I've ever created is being killed immediately after working successfully.
Yeah.
So that was kind of the goat side, and it was very despondent as an engineer. I was very despondent that that happened, but I've learned along the way, and there's actually a whole field called merger and acquisition integration, who do data integration post-merger. I had no idea to a few years ago that this field even worked, even though I was kind of in it on some ways. And that's what happens. You do this data integration work, it's done one time, and then you go away and do the next data integration project. But it's often done with custom proprietary software.
Yeah, that's awesome. It's merger and acquisition. That's like how do we get this square peg into a round hole team? Huh? Yeah. All right, cool. Well, that was awesome. By the way, I can teach you how to speak Australian real quick.
Okay.
So I'll
Oi,
tell
oi,
you
oi.
how to say razor blades, okay?
Yeah.
Say rise up lights fast.
Rise up lights, rise up lights. I got you. I get where you're going with this. I don't want to perform anymore.
All right, okay, yeah, that does it for time anyway. So I do want to get next month's topics figured out. We did have one volunteer that threw out some things. Does anybody else have anything they would like to hear about or would like to speak about? Okay. So one topic that was brought up was basically like how to clone a repository, make changes, push it up. Very like, intro level kind of topic. Does that sound interesting to people here? Like how to, get into like the whole GitHub flow? We got a couple. Okay. Sweet. Then, yeah.
I had another suggestion.
Sure.
Topic that sounds interesting to me. I'm an entrepreneur. I'm working on revamping a very old system. So I'd love to hear about experience stories, taking something that's, it's all written in C#, it's old, it doesn't have relational databases, and turning it into something that works in a modern context.
Like
You can talk to him
refactoring.
offline.
Oh, sorry?
A refactoring talk.
Good refactor, yeah.
Yeah.
But for a whole application.
Yeah, do we have any volunteers for a refactoring talk? We've done a refactoring talk years and years ago. Cody has been voluntold, I think, just now. But you would do one? I don't know about C# though, per se, but you could do a general refactoring. He could probably do a general refactoring talk.
Yeah, because like we have the example of like back in the vehicle history.
Good point. Yeah, so Cody just mentioned that there was some past work experience we both had where we had to revamp some old stuff and rewrite it. So cool, okay. Well, maybe we do this. What if we kind of split up between two talks? Because that way kind of you don't have to rush slides together, So we could have the GitHub talk as well as a refactoring talk. Cool? Okay, awesome.
The only issue I can think of is the refactoring is making engineer kind of apply technology.
Yeah, so it was said making the, refactoring talk kind of generic, because obviously refactoring in the sense of like a specific language is very niche, but a general one is fine. In fact, I would recommend looking up, I'll send you slides from another talk I've seen about refactoring. That's pretty good. Cool. I think then that wraps it about up. So again, thanks to Vegas Theater Company, Corporate Co-working. Thanks to Ryan for putting this up on YouTube. Again, you can see all of Vegas programmers' past meetups there. Again, with demo time, we have one slot left actually now. So if there's something you'd like to demo, definitely get that in. In fact, I think you actually take the last slot. I don't think we have any slots left, if you want to do it next month.
Yeah, I'll show you where we're at next month, and I'll show you not our staging, but our depth, so you'll see kind of what's coming up in the future.
Cool. And then what was your other talk about, by the way? You had two talks.
So augmented engineering has like 3 pillars. So like I said, one is code generation, one is low-code document interpretation, and the other is AI. And so I can do talks, like I gave sort of the approach of using a low-code document to do certain complex programming in this speech, but I'd like to show you how we generate code and do things like that too. But it's up to you. I can do this in months or weeks or years, whatever. I feel like the stuff I'm presenting is foundational. Like it's not gonna, it's like I don't want to do something that's going to be torn down and changed like every piece of technology is. That's why files, APIs, databases, and streams, theory of everything. I only want to work on foundational stuff at this point in my career, and I want to spend the rest of my career working on foundational stuff.
Yeah.
It's not going to change.
I got a quick question. The code generation that you said, is it generating, it's also generating the custom SQL code?
Yes.
Because that's where sometimes I have to write the queries.
Yeah.
Sometimes with Laura, with the search field. I'm a software engineer, so
sure.
naturally I struggle with the numbers.
Sure. So if you're familiar with ORMs, right?
Yeah.
Like often ORMs, initial strategies for ORMs were to generate the stored procedures behind the scenes.
Yeah,
so we do some of that.
Basically raw.
We use some of that stuff, but that's the middle layer is what's most interesting to me, because we have a technique that once you build that stored procedure, whether it's generated or by hand, a little syntactic sugar that allows us to not build any more middleware code and make calls directly to, like essentially running a stored procedure as a web service. And in our approach for building front-end software, our stored procedures become web services because our middleware engine essentially does the translation, so there is no middleware code necessary. And we started it with Postgres, where we can push JSON out of the database pretty elegantly in Postgres. But we're going to take that out of Postgres and put it directly in our middleware, which is probably where it should have been. But so I do have answers. It's a full stack concept when I'm talking about the front end code generation stuff.
When you say front end code generation, that means it generate the JSON schema definition.
Well, it generates. So where we have it now is we can generate React code. We can't yet generate React native code, but there's no. We're not. Okay, so we can generate React code. We generate it because users pick a template of, let's say, what they want to build. So I want to build like a CRUD, create, read, update, delete. And that code we are able to take that templates that are pre-built, and then generate the code from Java in the middleware, and then save that React code into GitHub. So then an engineer, so an analyst can do all that stuff with no programming is the thought process here. And then a software engineer can take that code base out of GitHub. And what I'm trying to do is to make it look like it came from another engineer, but a really good organized engineer. And it doesn't look like generated code, which a lot of it's been crap in the past that we've all seen as developers who's done this a long time. It's really important to me that the code that comes out of my generation library looks like code that I would have personally wrote.
Yeah, if we can do, I think it's a really innovative way of doing it, because right now I cannot understand
I would love to demo that for you.
Sweet.
There's my
Yeah.
audience plant.
Yeah. Cool. Yeah. All right. Sweet. All right. Well, thanks everybody for coming out again. I really appreciate everybody's support. Well, are you heading over to Taverna, Andy? Yeah. Yeah. If you want to catch us after and talk with us about anything specific, we're going to head on over there for the launch party. And yeah. So thanks everybody, and we'll see you next month.
Thank you for the opportunity.